The Atlantic Ocean region contains approximately 2 times 10 to the 16th power gallons of water. Lake Ontario has approximately I don't even know how you would say that number. It's not trillion. Maybe it is trillion. Million, billion, trillion. Yeah, so 8 trillion gallons of water. How many Lake Ontarios would it take to fill the Atlantic Ocean region in terms of gallons of water? So first we want to be able to compare them. So we have to convert them to the same type of format. So either we change them both to standard form or we change them both to exponential form. Personally, I think it's going to be easier to deal with them in exponential form. So 8 with 12 zeros behind it. Is that 12? 3, 6, 9, 12 zeros behind it can be rewritten as 8 times 10 to the 12th power. Now it's kind of hard to determine which type of operation you need to do just based on these numbers, but if we were to look at something like saying the Atlantic Ocean has 2,000 and Lake Ontario has 80, we could figure out how many Lake Ontarios it would take by dividing. So we're going to do the same thing, but we are going to divide using exponential format. All right. So 2 divided by 8 gives us 1 over 4. It can be reduced. And then 10 to the 16th divided by 10 to the 12th. Well, remember, when we have the same base of 10 and they're divided, we can subtract those exponents. So it's times 10 to the 4th because 16 minus 12 is 4. But a quarter can be rewritten as 0.25. Okay, then it says how many Lake Ontarios would it take? So we want to get rid of the exponential format and just figure out how many it would actually take. Remember, this 10 to the 4th tells us to move the decimal place 4 times. So let's do that. 1, 2, 3, 4. So we're going to fill in those empty spaces with zeros, which means it takes 2,500 Lake Ontarios to fill the ocean. Two says U.S. national forests cover approximately 300,000 square miles. Conservationists want the total square footage of the forest to be 300,000 square miles. When Ivana used her phone to do the calculation, her screen showed the following. What does the answer on her screen mean? And explain how you know. Okay, well, if we did 3 squared, that would give us 9. And there are 1, 2, 3, 4, 5 zeros in it. So if we doubled that, that would give us 10 zeros. So if we took 3 times 10 to the 5th, because there's 5 zeros, that's how we would rewrite it, and we squared it, well, the 3 squared would give us 9. And when we have exponent to an exponent, we multiply those exponents, so it would give us 10 to the 10th. So this screen means 9 times 10 to the 10th because 300,000 squared equals 9 times 10 to the 10th power. So one way that they write it on your phone, if they don't have enough room for all 10 zeros to come after it, is they say the exponent is a positive 10. So the exponent on the 10 is a positive 10. B says, given that the U.S. has approximately 4 million square miles of land, is this a reasonable goal? And explain. So the conservationists want 9 with 10 zeros behind it. But there's only 4 million. 4 million has 6 zeros behind it. The U.S. has 4 million square miles total. Is there enough space for that much land, 300,000 squared, to be designated for national forests? No. That is more land than the U.S. has in all, or in total. You can't have more forests on the land if you don't even have enough land to cover it all. The United States is responsible for about 20,000 kilograms of carbon emission pollution each year. Express this number as a single digit times an integer power of 10. So the number we're going to use is a 2, and the power on the 10 is how many zeros come behind it. So 1, 2, 3, 4 zeros follow, which means you should have 2 times 10 to the 4th. The UK, or the United Kingdom, is responsible for about 1 times 10 to the 4th kilograms of carbon emission pollution each year. Which country is responsible for greater carbon emission pollution each year, and by how much? So the US has 2 times 10 to the 4th, and the UK has 1 times 10 to the 4th. You can subtract these numbers to figure out the difference, but the key thing here is these have to have the same exponents. Since they do, all we have to do is subtract the pieces out front and keep the exponent on the 10. We could also look at it like this. This would be 20,000, and this would be 1 with 4 zeros following it. So if we were to subtract, we would get 0, 0, 0, 0, and 2 minus 1 is 1. That's a 1 with 4 zeros behind it, which is the same as what we have here. By how much? This is kilograms. Make sure you label it with units.